Hey, look at that. Ah, hi, Tunnel Man.
How's it going?
It's going pretty good.
Yeah.
How are you
Well,
doing
you're
today?
looking good. You're feeling a lot better, aren't you?
Well, I actually had kind of a slightly rough week, but for whatever reason, I got better yesterday. Yeah, it's weird. I put a little foam under the top of my mattress or on the front of my mattress to raise it up a little bit.
Yeah.
And I find if I sleep at just even a 2-degree angle, I'll sleep fine. And if I sleep flat, I'll wake up. I can't get to sleep. I like wake up and have all kinds of trouble. So I got brave and I took that foam out this week, and then I suffered for 2 days with no sleep. I put the foam back in. I was like, what am I doing?
Yeah. Well, at least you know what it takes to get a good night's sleep, though.
Oh gosh, yeah, it's crazy.
know.
But yeah,
Well, I'm happy for you.
yeah. How you feeling? Good? You're staying out of trouble? Hey, Renan.
Hey.
Hi, Siddharth.
Hi there.
All right.
Hey, John.
Hi.
Hey, John.
What have we got there?
All my favorite people.
Hi, Terry.
It's so good to see John, and especially since we don't have to drive all the way over there.
Yeah.
Yeah.
No bags under his eyes or anything. Yeah.
Yeah. This is a good way to do it because I may have been exposed to COVID last weekend.
Oh
Oh,
my
no.
gosh. I hope
Well,
not.
my friend got possibly exposed where he works, and we spent last Sunday together. So yesterday he got a test, and he gets the results tomorrow or Monday.
Okay. So he's not sick yet, so that's good. But
Well, that's good because, and I'm not.
yeah.
So I
So are you
suspect there's nothing to worry.
Are you going to get a test, John?
Depends on whether he comes out positive or negative.
There you go.
But even if he comes out positive,
Uh-huh.
who cares about the test? I'm either
Right.
going to get sick or I'm not.
Yeah.
Right. Right.
If I get sick, then maybe I'll go get a test just to verify whether it's that or just some other flu bug or something.
Yeah.
Yeah.
Yeah. I haven't heard of anybody with a cold. Have you heard?
Yeah.
I don't know anybody who's had a cold lately. I think the common cold's been pretty much wiped out. Because
I had one last week.
did you? Wow.
Just
Okay.
Just a head cold.
Yeah.
Yeah. Congratulations.
You're keeping it alive.
I got it right after I talked to Terry on the phone.
Oh.
Can it be electronically transmitted?
Yeah.
Yeah,
Yeah.
that's been my theory. Yeah.
Yeah. That's what we came up with.
I was gonna go visit a guy up by Stevens Pass, a contractor out at Cole's Corner, and then the day I called him the day I was gonna go out there, and then he says, "Yeah, I got this cold, horrible cold from my granddaughter, but come on out." I'm like, "Nope."
No thanks.
Yeah, gee, I could wait. Oh my gosh.
I've been planning to get a regular old flu shot, but with that head cold, I didn't want to do it. Now, I guess I'm going to wait and see if I get sick from this other thing first.
Oh boy.
Yeah.
Yeah. Normal people have always thought you were sick.
Yeah,
Well, most normal people are sick, so there you have it. Nice. Hey, Howard. Well, hey, Howard.
there he
Welcome
is,
to the
yeah.
Looney Bin.
Howard, hi.
Hi, Renan.
Hi.
Hey, Terry.
Hey, how's it going?
John's there somewhere, huh?
Yeah, John's got a pretty nice setup there. I like his cabinet. Man. I mean, it doesn't have enough speakers in it, but other than that, it's pretty.
Yeah.
Have you seen Costco's sale flyer that has like a bedside or a couch side table? It's a round speaker with the kind of tapered metal legs that are kind of 60s, 50s or 60s kind of, you know, Moonlander kind of look.
Wow, I have not. Now I'm curious.
It's on sale for $279 or something like that. So I assume it's Bluetooth, and you know, it's probably kind of Omni or something.
Right.
It you know, it's in the round, so.
But it's a coffee table. Oh, there it is. Look at that. See if I can. The worst way to show everything. Here.
Oh yeah, nice.
Kind of interesting.
So
Well,
could
okay, it's 3 legs. That's good. That makes sense. Yeah. I was thinking it was 4 legs, but yeah. So enough cabinet space there to actually have, you know, pretty full sound.
Oh yeah. I have been tempted to make a speaker shaped like a one of those lamps that's, you know, just got a base, a slender pole, and then the lampshade.
Right.
Because I thought you could hide everything in the lampshade, you know, and put a thin panel of LED lit lampshade, and then have the interior be the speaker. So it would look the same. It would still light in all the same directions, but it would be a speaker. But I have not gotten around to doing that.
Number 137, right?
A million ideas.
Well, you remember on a typical floor lamp how they've got the big bulb in the upward facing glass bulb there. You could put the speaker there with some kind of like a you know.
Oh yeah.
A 360 diffuser like some of the old speakers had.
Oh sure. Yeah.
You could do a single driver with a backloaded horn that was just the length of the stand. I mean, would it have to be hollow and taper one way or another, probably, or just transmission line?
Yeah. Wow.
But it would be a kind of a fat vertical part.
Yeah. I was gonna go find the thing I had to talk about. Let me see if I can. I did a couple of funny things. There's one of them, and let's see, where's the other one? Documents. Aha. So I'll share my screen here. Maybe. There we go. Cool. So let's see if I make that bigger. Oh, there we go. That's a little bit better.
wow, looks nice and flat.
So I've been playing around with, you know, trying to make a baffle, and for this speaker for Tim, and anyway, so I was, you know, I love to use the Boxsim. So this is using Visaton Boxsim, and then I just said, oh, what if I put a it's 100 millimeter, 4 inch driver into a 1 meter baffle, just a big wide one, and put square in the center. And so the black curve is the driver, just kind of it's on its own, and then the blue one is when you put it in the baffle, and you can see the ripples due to the edges, the diffraction.
That's not bad. That's not a real bad ripple pattern, though.
So
Actually,
it's up and down like 2 dB.
yeah.
Let's see. There's 2, 4, 6, 8, 10. I guess that's 4 dB down. That's 3 dB up. -4, 2. Each line is 2 dB.
Yeah.
Oh, okay.
Makes sense of that. I don't
That's
know if
significant.
make it a little bigger here. There we go. That's probably a little better. And so then I said, well, that's a huge baffle. Let's make a couple of smaller ones. So this is a 12.5 centimeter baffle. So, yeah, if I was smart, I could tell you how many inches that is. I'm not smart. Okay. Oh wait. 10 inches approximately. So that's a 10-inch wide, 10-inch tall baffle. And so I did 3 configurations, one with it right in the middle. I guess, yeah, you can see there's a 4-inch driver. It kind of gives you an idea. And so you can set where it is with these parameters. That's the height and width of the baffle, the thickness, and then you can also put these chamfers on the edges, which I didn't do. That would actually reduce the problem. Then I did one where I moved it over with this ratio of 1 to 1.5. So the idea is the wavelength, if the wavelength here is 1, you'd have 1.5 wavelengths over here. So a full sine wave here would give you 1.5 sine waves to get to that edge. So then the diffracted wave from this edge would be out of phase with the diffracted wave at this edge. So that should give you some cancellation. And then this one, I moved it so that it's 1 to 1.5 both horizontally and vertically. So this should give you cancellation both from the horizontal and the vertical, if that makes sense. So then here's the result. This is just the centered, so you can see we got whatever. So interestingly, the smaller baffle has fewer ripples. This was not intuitive to me, but that's what it says. But anyway, so you're up probably 4 dB, you're down 3 dB. So that's the centered, so that's the worst case. And then this is with the offset to a horizontal offset. And so you can see it's come down a little bit. Now we're just 2 dB down. And then if you center it, or I mean you offset both horizontally and vertically, now you're only down about 1 dB. So it's interesting to see the effect. I should have found a way to overlay these, but you can see it. That's kind of the worst, a little bit better, and a little better still. So that, well, yeah, 1 dB is pretty much. So then I did it do much to this bump? So this is probably 3 dB. That's a little more. Yeah. So anyway, so that was kind of my experiment in math, making no sawdust whatsoever. So.
Well, Dana, what would you think about the practicality of the idea of, say you had a driver that had a peak at 2100 hertz, and then you'd center it on the baffle that way, and it would help to mellow out that peak. Do you have any sense whether that kind of idea would?
Oh yeah, that'll totally work. Sure. I mean, yeah, I can't see any reason why it wouldn't. You're just relying on that the diffraction to do that change. And then I didn't have time to show the off-axis response, but maybe I'll do that next time. But not to.
So
Dana?
those are let's see, 2005. So that dip above 2000 is about 1,000 hertz wide.
Sure. Yeah. Roughly.
Right.
Yep. Yeah, John.
I was just saying,
it wouldn't. Yeah, it'd be good for kind of more gradual. Well, it'd be good for the kind of stuff that shows up in a third octave smooth graph.
Sure.
Basically.
Well, one of the things that I learned was that it's the dips you don't hear very well, and the peaks really stand out.
Right.
So if you have a short duration dip, you probably won't hear it at all. However, short duration peak will be heard.
Yeah.
So,
I've found that too. I don't listen to dips.
yeah. I don't talk to myself anymore either.
So Dana, did you try a non-square baffle?
I have, and the results are similar. It just shifts the frequencies around.
Uh-huh.
And so you can do that as well. You can, by making the baffle ratio, you could move this peak. Say you got this peak and this dip because this is the vertical height. You could make the horizontal so that the horizontal dip occurs where this, and you could cancel it by making the ratio vertical to horizontal. So you can get much smoother by making it not square. I was just trying to make it the worst case here.
Yeah.
So we could see it. But certainly, yeah, you do it, whatever, a 2 to, or a 1 to 1.5 ratio of the height to width. And I think you could wipe out some of this, you know, because you ultimately end up with this, right? Or, well, you end up with this. So you could, yeah, so there's, by playing around with it, you can definitely do, you can optimize this thing, yeah. And the beauty
What
is you do it here,
what about
just twiddling the
what
numbers.
about an oval? What about an oval shape or something like that?
Oh, sure. So then it's gonna, what the
Would that-
oval's gonna do is it's gonna smear this all over. So, you know, you say the widest part of the oval might be one frequency and the narrowest is going to be a different frequency, and it's going to smear it across there.
Just because of the varying distances?
Yeah, yeah. Well, and you also have varying distance even with a square, you know, with a straight edge, you actually
That's
have a
true.
varying distance.
That's true.
So it's, yeah, it's really weird to think, you know, more I think about it, you know, I'm like, oh yeah, of course, because as you go at different angles, you're getting different distances. Yeah, it's complicated.
That's what you have to remember when you're doing these, that there's going to be a gradient of roll off or peaking, and
Yeah.
sometimes it's not that noticeable, honestly.
Right. But so that was, yeah, it's just kind of fun. And my other thing I did this week was I hauled out some a tweeter. I bought a pair of these tweeters. They're hard to find. And the guy said, "Oh, I got one good one and I got one burned out one." And so I took apart the burned out one just to see what it looked like, and it was kind of fun. This is out of a Speaker Lab speaker from the 80s, and it's a pretty nice for the day Foster ribbon or leaf tweeter. So this was their high-end Speaker Lab sold it like as the LT215, and this was I can't remember the Foster number, but it's kind of fun. The it's got these whatever samarium cobalt magnets on both sides, so there's some behind it on this heavy machined plate, and then just a circuit board basically. And so this was kind of fun to see how they had laid it out so that the you know, this is one of the connections, and then you watch how the trace goes, and it goes here, it goes across, and then it goes around this loop, and it goes back, and it goes around this tight loop, then it goes back, and then it loops back all the way around to start over on the second trace. It's going back, forth, back, and then around. So the whole thing is in series until you get down to here. So it's kind of fun to see how they kind of laid it out according kind of like the lines of flux from the magnets sort of looks like, doesn't it?
Yeah.
But I thought, well, if I get real brave, I could lay out a new one. You can buy these circuit boards in any thickness you want. So you could actually order, this is a sandwich of a fiberglass and then a, whatever it is, the Mylar, a really thin Mylar circuit board, and then another fiberglass one. So it's actually doable to like lay this out yourself and put an order and get it probably for, I don't know, probably 30, 40 bucks. I could get one of these made.
Probably Kapton, isn't it? That's
Yeah,
yellow.
Kapton, that's the right. Yeah. It's Kapton's a variation of Mylar. Yeah.
It's a lot more heat resistant though.
Yeah, it's the high temp, version. Yeah. Yeah. So anyway, so you can see what happens when you drink and overdrive.
Yeah.
But so yeah, it's kind of fun to see. It's such a beautifully made. It's made in Japan. This is a really heavy machined part, and so it's a shame to have it burned out. You can't. Apparently, I have never seen anybody selling this replacement diaphragm for this thing. But of course, you could buy a brand new tweeter that. Oh, there's my blood pressure. But anyway, I will return to our normal programming. Woo!
Well, Dana, I had a
Oh, hey, I know that guy.
There's the
Hey.
Norsky.
Hey, he's got the haircut I didn't get.
Nice.
Maybe he'll share it with you.
Dana, on the Boxsim, are you able to load the frequency response data file into the into that, so you could put a particular driver on that baffle?
Yes, you can put any driver you want. You can model it with feel small parameters, or you can model, well, in addition to that, you can also load in measured impedance and magnitude phase, you know, measurements. So you just go in there and just pick arbitrary driver close in size to the one, you know, in their catalog, and then you just overwrite the parameters once it's loaded into the program.
If you wanted to tune a particular driver to a particular baffle, you'd have to do something like get a, you know, mount the driver into like the wall of the house outside or something like that, away from everything else, so you could get a really neutral, not refracted measurement, right?
I think it accepts like 3 different measurement baffle types. So if you'd want to pick one of those.
Okay.
So yeah, so there's like,
does it compensate for does it compensate for those standard baffles?
it does.
Oh,
It does.
okay. Oh, okay, I see. All right.
So yeah, before you start, it would pay to go into the program, see what those 4 baffles are,
Yeah.
and pick one, do that.
Right. Okay. Thank you.
Yeah.
Thank you. Was Dave about to say something, or was he just saying hi? I'm here.
No, sorry I'm late. I had somebody ran over my mailbox overnight, and I had to go tend to that. So.
Oh, yeah.
How could they run over your mailbox? Isn't that right at the top of your driveway?
That's awesome.
Well, there was skid marks right there on the shoulder, right up to it, and just beyond it. Luckily they stopped before the end of the dead end.
Oh my
They were
God.
Yeah,
they were so drunk they didn't realize it was a dead end, right?
Yeah.
Occasionally that happens, but I have.
yeah, that's a real dead end too. It just stops.
Yeah. Well, there's a little bit of a ditch and bushes and stuff, so that would stop anything, I think, eventually.
Yeah.
Yeah.
Bushes and trees back in there that's uncleared.
That happened to my parents. You know, when I was young, somebody just plowed over our mailbox, and the guy stops, you know, obviously, and he comes over and tells my parents, "Oh, I'm so sorry. I built this house and I was admiring it as I drove by." So,
Yeah. Well, I have bits and pieces of the plastic bumper fairing of a white car and a black piece off the bumper. So
well, when
plastic stuff.
When you rebuild, you should glue those wrapped around the new pole.
Yeah.
Yeah.
Yeah. Buddy was telling me about a fellow out in Maple Valley that kept losing them. And, you know, on Wednesday night, he'd hear and a smash, right? And so he kept hitting his pole. Finally, he got a metal tube and filled it with concrete and put his mailbox on that. And sure enough, Wednesday, he hears an accelerating car and a big crash. And he found bumpers and pieces of fender and stuff for about a quarter mile down the road. It just, car disassembled itself. So I think that's highly illegal too, but serves them right just the same.
Well, these guys have some car damage they're going to have to deal with. So
Yeah.
the vengeful side of me feels a little bit
Good.
avenged on that. But
Nice.
you know, it would be nice if they would leave a note and say, hey, I did this. I'm sorry I didn't have time to stick around. Let me know what it takes to fix it, you know.
Yeah.
You could,
And
when you
then I
build
wake
it
up.
Dave,
Yeah.
And
when
then
you
I wake
build it-
up to reality.
When you build it again, you ought to put like a big spray paint bomb in it. And if they hit it, it just blows paint all over them. So they,
Yeah, I thought about that one time. I had problems in another area. I was gonna get one of those paintball guns set up, and so it would pull the trigger on it.
Well, you could just duct tape full cans of spray paint up the front edge of it,
Oh
right?
yeah, yeah, I could. Now, so they broke off the 4x4 flush with the ground, so I'm gonna have to dig that out and put a new one in.
Oh my gosh! Wow. So Renan, do you have any thoughts
Yeah.
on streaming audio out to a mailbox?
Yeah. Yes.
So they can deliver.
So I've been toying with the idea of being able to stream music from Amazon or Spotify or Qobuz or I've forgotten the other one. That's also pretty good. But a way to do it without having to buy an expensive streamer of some sort, you know, which has Rune capability and pay for that. So I found out that JRiver has a driver that comes for free with it. You just turn it on. And what happens is that anything you play on your computer that has JRiver on it, that driver will then redirect all sound, all music through JRiver. And from JRiver, you can then stream it out to your big system. So instead of playing your music on your laptop with an app or on your iPhone with an app, how about if you want to play that same music out on your big system? How do you do that? You know, without spending a lot of money. And it turns out that JRiver gives you that capability. So this driver is called the WDM driver, and it's available under, I'll send an email around, but it's under Tools, Options, General, Features. And then you check mark the WDM driver, restart JRiver, and then from that point onwards, anything that you play on your PC is directed through JRiver. And then from JRiver, you can, you know, obviously direct it to whatever sound card or streaming device or whatever that you want to play your music out to your DAC. So I thought that was pretty nifty. And the reason I tried this is because Amazon HD Music is for $14.99 a month. I've just did a trial subscription, but $14.99, and you get full definition music, you know, either 1644 or higher, not uncompressed, in other words. Whereas any of the competing companies like Rune, et cetera, the price is twice as high. Just for a regular uncompressed music, it's $24.99 on Qobuz and on Tidal. So I thought, you know, at half price, the selection is not bad on Amazon. So I've been streaming some of the music from there at 1644 and higher resolution. It sounds very good out on the big system, I mean. So I thought I would just mention that if you do have JRiver running on your laptop, you can now stream pretty good resolution music out to your big system.
Renan?
Yeah, go ahead.
Yeah. When you say the big system, do you mean the one upstairs?
Yeah, the one upstairs.
Oh, okay.
Instead of playing the music on your computer, which you can do, you know, how about if you wanted to play that same music full resolution on your hi-fi system?
Right.
You know, so the idea was to see how to do that. And was there an easy and cheap way to do that? And it turns out that there is. And folks have done this. You know, I just found it on the JRiver website. that people have already done this. So I tried it. It works quite nicely.
Oh, neat.
And
So,
it only took a
Renan,
few. Yes.
is that a wireless transmission from your laptop server to your system then, somehow? Or is there a connection in there?
Well, I have a Ethernet streaming capability,
Oh.
right? So
Okay,
I stream it out through the
okay,
Ethernet,
okay.
or if you had Wi-Fi, whatever output device you set in JRiver, where you want the music to go, that's what it'll send it through to.
Okay.
So yeah, so all music and sound is directed through JRiver. And I thought that was pretty nice because it doesn't alter anything. You know, it just
Oh, nice.
grabs the signal and passes it along to the appropriate output device that you've chosen in JRiver. And you can always turn it off. I mean, you know, you
Yeah.
don't have to, you can turn it off and then play your music on your computer if you wish, and then turn it back on and play it through to your system if you wish. And that was nice because, you know, that way you can listen to something, you know, and in decent resolution, uncompressed, out on your system and see what it sounds like. And yeah, so that was my current thing I've been messing about with.
Now, Renan, you have about 29 different ways to play music now, don't you?
Well, you know, two actually now, you know, just through streaming with your own music files,
Yeah.
and then streaming from the internet, but through JRiver. So yeah, there's two ways to do it.
Oh, so there's not 50 ways to use your server.
You've been watching naughty movies.
It can get complicated because when you play Amazon Music, you know, you have to use Amazon Music, their player on your computer to play the music. You know, the files don't just show up in JRiver. You have to play it from their player, but it gets routed through JRiver out onto your system. So in that sense, it's kind of peculiar because you have a number of players. Each one has their own player, like Tidal has their own player. But it's the same thing as an app on an iPhone. You know, when you want to play Tidal music, you got to use their app. Same thing. Except if you use Rune, which then seems to combine all of them into one interface. But you pay a price for that.
Oh,
Yeah. Yeah.
So anyway, yeah, that's what I've been messing with currently.
That's kind of neat.
So you're gonna send out an email?
I'll send out a short note on that with a link to the JRiver page that describes how to do it.
Okay.
Yeah.
Yeah. Oh, and Renan, I did talk to William Goldman.
Yes.
Yeah, it's a fellow who's transporting some big speakers across the country and wants boxes made for them.
Right.
Yeah.
I'm glad you could help him out because he is kind of stuck for being able to do anything like that. He's very worried about his speakers.
Yes. They're Infinity. I guess it's a RS1 thing. It's a
those are big, yeah.
5 foot tall woofer tower and then ribbon tower.
Yeah.
Yeah. So yeah, it was nice to meet him, and I think I'm a good one to help because I do care about the speakers where another carpenter might just, you know, not quite get it.
Right.
Yeah. So thank you.
He has a nice system. Audio research, I believe. It's quite a good system.
Yeah.
Yeah. It's too bad he's leaving, going back to New York.
Yeah.
whatever.
Yeah.
Family issue, so
Right.
it's got
Right.
back.
Right. Right.
Yeah, he's a good guy.
Man.
Yeah. Yeah. So, I was wondering if there might be a less expensive or involved way to do it. Like there might, like Genesis might have packing materials. I talked to Gary's sister in Woodinville, and she said, nope, that's what we do. We get plywood and 2x4s and construction adhesive and screws, and we just go for it. And they actually go to like the Michaels or somewhere and buy like stiff foam, like foam you'd sleep on in a camper or something like that, I guess, that type of stuff. Well,
Oh, boy.
the materials are expensive. Just the materials are expensive for the project.
Oh yeah.
Hey, Howard,
Yeah.
I have some input on that. I've had a good and a bad experience both with shipping some IMF TLS 80s across country. The bad experience was I boxed them up. They came from Atlanta in 1990, and 5 feet in front of my door, the guy who was unloading the moving van, I said, "Hey, I'll move those myself. Let me take them." And he said, "No, I've got it." And he dropped one box on its corner and ruined the cabinet. The good experience was I bought yet another set of TLS 80s from a guy in Atlanta, and what I had him do is just put them in the original boxes, set them coffin style on pallets, and they arrived in perfect condition from Atlanta. So the fact that you're building good boxes is great, and I would say, if I could add anything to it, I would say just strap the boxes coffin style to some pallets, so there's no way that whoever handles these things can drop them on their heads or tails. Just FYI, just if that helps.
Yeah, I mean, William is quite convinced that the way to transport the ribbon panels is vertically. In other words, in standing like they would, only surrounded. And I think that's probably best as far as any kind of just road wear, movement kind of stuff. But if they fell over, if they weren't secure enough, then that would be disastrous. So like, I mean, yeah, that already having them horizontal, like you say, and all tied onto a pallet kind of prevents that type of thing for sure. But your kind of thing, they would have had to take it off the pallet and bring it in the house. They still might have dropped it, right?
Well, when the things were shipped via pallet, I actually went out to the airport and met the FedEx plane, and I rented a van, and I just lifted the pallets myself into the back of the van. So there's no way they could have unhooked the boxes from the pallets. So the pallets remained ass end down the whole time from Atlanta. So, and they were fine. They were perfect. They were perfectly wonderful cabinets. So
great. Yeah. So yeah, it's an interesting project. He doesn't want to build boxes for the woofer cabinets. Like Dana, was that you that put up the photo of the speakers?
Yeah.
He doesn't want to build boxes for those. He wants to wrap those, and I think they ought to at least have something rigid over the woofers. And he was kind of going, "Oh, we'll just put moving blankets around them." And I was going, So,
yeah, those are,
hey, Howard, have you guys fixed or has he fixed a shipping company?
that I don't know.
Well, I have a suggestion for a shipping company who's up in Southern California. If you need a suggestion, they actually specialize they work with PBN audio, PW Norback audio, which has very large speakers. They're the company of choice that PBN audio uses to ship all their large speakers all over the country. I have used them personally. and they're called Saturn Freight.
Oh, like the planet?
Yeah, Saturn, the planet Freight. They're up in San Diego, Southern California.
Okay. Yeah, it's yeah, I don't have any idea what type of carrier he's using. Whether I was kind of assuming it would be like moving company that would be moving his personal belongings and these together in a probably in a big.
Well, the reason I'm mentioning this is because those guys are, because there are two companies up in Southern California that build very large speakers that they use for this. So rather than using a one size fits all, whatever moving company, this is a company that, there's no guarantee, but basically they have moved lots of large speakers. So they know the whole thing about speakers,
Right.
how to be careful about them. So it's, given that it's a good speaker and you want to transport it, it may be wise to actually contract with a specialty company that actually moves big speakers.
I'll suggest that to him. I don't have a strong sense of what his budget is.
And they're very economical because they actually, find the best deal for you. So I've been quite surprised by how much they charge for large distances. So just FYI.
Thank you very much.
Yeah.
So does anybody have anything they've been working on they want to talk about?
Well, I found one little thing that I can just tell you about is Dana. I asked Dana the other day about a design that Rod Elliott had online for a passive inline between your preamp and amp or source and amplifier type of passive crossover. And I actually found some on Parts Express that are they just look like cable connectors, and it's Harrison Labs.
Yeah.
If you Google Harrison, if you search Harrison Labs on Parts Express, there's just a mess of these little things that come up, and they're everywhere from 50 hertz up to a few thousand hertz, and they're just 12 dB crossovers that just go in line, and they're not powered or anything. You just plug them into your cables, and they'll roll off whatever you plug in, whatever amplifier you plug into it. And
cool.
So I was thinking about using those. The reason why I was thinking about that was thinking, I'm using a plate amp right now for the bass section on my surfboard, and so I was thinking, well, if I wanted to use some other amp, and I didn't want a big electronic crossover on all the time. This is one option, whether it would actually do what I want it to do or not, but I thought it was kind of a cool thing. So
you'd have to know what the input impedance you're dealing with.
Yeah, I don't know the technical. They don't give a lot of technical details on the product page on Parts Express. But and then most of the comments are from people that have used them in car stereos and that kind of stuff, where it's like not being terribly technical about it.
You might have to try it and measure it.
Okay.
Just because without knowing what the impedances, the input and output impedances are, you don't know exactly what you get.
Right.
In terms of crossover point type of thing, or roll off, where it starts to roll off.
Yeah, what frequency you'll get.
Okay. Right. And probably the best deals. Dana's always been nudging me just to even borrow and try his mini DSP, because that's what's going to really dial it in. It's probably what it really needs to get it really right. Because when I have the level of bass that I want below, say, 80 hertz, with the rest of the speaker, I end up with kind of a depressed kind of a Bose sound, kind of a depressed, maybe 150 to 250 hertz, something like that. It's just not as warm through there. It doesn't, yeah. And then if I turn up the 18 dB crossover on the plate amp, it's just too strong in, I don't know, maybe 120 hertz or 120 hertz, something like that. So I think that mini DSP is the way to really probably do it right.
It gives you lots of knobs you can turn forever.
Yeah, right.
Hey, I've got a subject I'd like to throw out there, and that is, what do people, you guys, do to clean your equipment, say during the winter and you want to dust it off and all that? How do you do that without erasing print on the cabinets of your gear, or smudging something, or getting the plexiglass windows clean, or whatever? What type of stuff do you guys use?
Yeah.
Oh,
I use compressed air.
Something stronger than water, right, Terry?
Yeah, but you're talking about, yeah, I usually use a vacuum cleaner and compressed air between the two, but mostly that's just for dusting.
Yeah.
I don't know about other stuff, but yeah.
Yeah. I don't mean there's as far as household cleaning, there's like vinegar pops up all the time, as far as, but I haven't tried it.
What is it?
Vinegar, white vinegar.
Oh, vinegar. Okay.
Yeah. I don't think that would tend to take like ink off or whatever,
Yeah.
Ink or anything.
But yeah, usually equipment says use a mild soap and a cotton cloth, or something.
Right.
But,
Okay.
Water on a cloth gets most of it usually, and
yeah.
yeah.
Yeah. But
I have two things to contribute. A question and an answer, maybe. About a year and a half ago, I have a D to A converter. It's called a Monarchy NM24, and I bought these Mundorf Silver Gold Supreme capacitors, and Rene actually installed them for me. They're it's a tube output D to A converter. It's a D to A with a small preamp on the end of it. And I put two of these, I think they're 2.2 microfarad capacitors in them. And a little over a year later, back in August, something started to happen to the sound of them. They developed more bass, and then they kind of sounded funky on alternating days. And then about 6 weeks later, I'm going through that phase, all of a sudden they just opened up, and this this $900 DAC turned into a $5,000 DAC. It took a long time for these things to break in, because being a tube DAC, I didn't want to leave them on playing all the time. But these two caps replaced the standard ubiquitous ELNA MKP red caps that you see in all this generic equipment. And so for $80 a cap, I can highly recommend that. And the second thing, I got my hands on what was probably a prototype of the Cardus Clear Beyond power cord. I won't admit to any more than that, but I paid about $100 for it. And I noticed there are on each end of I'm using this on the DAC itself, and it made a big difference in the sound of the DAC. Does anybody in the DIY community know? I'm sure it's got a coil and something else stuck on the, in between the very good wire. Has anybody made something like this with success? And if so, can I, will you tell me what you did, I guess, because it sounds really good. If there's no answer, that's fine too. But
I think I've seen people who've cracked open some of those boxes, or lumps in the cables, You might be able to search, you know, and see if somebody's documented cracking one of those opens, but you're probably, there's probably a coil and whatever in there.
Yeah, Dan Wiggins measured a bunch of coils years and years ago, real high-end stuff, and you know, the $20,000 cables, and he showed it to me, and between about 1,000 and 4,000, there was kind of a little dip in it. He says, "What does that look like?" And I said, "That looks like a BBC dip, like what you'd get with a capacitor and a resistor." And he says, "Well," he says, "that's what it looks like to me." Well, about 2 years later, now this is 20 years ago, there was a guy in, I think it was Denmark, that got a hold of these cables. He's a dentist and maybe has a lot of money, I don't know. He dissected the little, you know, the little bulge on the cable, and guess what he found? A capacitor and a resistor, and they weren't real high end either. So that's what they were doing 20 years ago. So,
yeah, I think Tim's talking about a power cable. So it's going to be really hard to get a BBC dip into a power cable, but you could try.
yeah. Well, I'm just saying that some of these things are,
Sure,
they trick it up a little bit. So.
Oh yeah.
Dana or Terry, is it reasonable to suspect that the designer was trying to filter out anything mostly above 60 hertz? In other words, is the function of a power cable to deliver pure 60 hertz, no RF, etc., or does a power cable have to have a wider bandwidth, but just not up into the megahertz and gigahertz range? Is that an understandable question?
Yeah, well, so if the equipment it's plugged into is designed properly, it has filtration in it to handle whatever the power cable can deliver. And yeah, all the power is at 60 hertz, the rest of it's noise.
Right.
So properly designed equipment will have that. You'll see sometimes, you know, when you have boxes that have RF associated with them, there'll be a lump in the cable, which will be a common mode choke. So, you know, like computer will have that, or you'll see it on a USB cable or things like that. And that's to prevent the device radiating that noise to other equipment. But otherwise, if it's just coming down a power cord, the first thing inside the box should be a shielded power supply that handles, you know, all the RF and whatnot you could throw at it, unless you're working in a, you know, a van next to a radio station tower.
Right.
I mean, if you happen to live on Rose Hill, there is a high power AM station that you can, you know, receive on your glasses or fillings, or, you know.
Yeah.
But in normal circumstances, you won't have trouble. Yeah.
Yeah. Weirdly enough, I actually found out that I have a turntable that's plugged directly into a moving coil preamp, and there's a street light right outside, and I found that if I terminated the MC preamp into 47K ohms, when the street light came on at night, my poor little phono preamp would pick up that noise. So I reduced the impedance to 1,000 ohms across the line, and voila, no more noise at night. So I couldn't find a perceptible loss in high frequencies, so I just kept the phono preamp at 1,000 ohms instead of 47, which would have been my preference. But I can use it 24 hours a day now. So,
well, that's a perfect example. So you hear the noise when the music's not there, right?
Right.
Yep. So if you don't hear noise when the music's not playing, I mean, that's the kind of thing that a filter on a power power cord, if you heard the noise and there's no music playing, then you would want to add some filtration, and otherwise, probably not going to be an issue. But I see Rene Yeager joined us.
Hey.
But I don't know if anybody else had comments, but
Thanks for your time, by the way, everybody.
I have a question, a technical question. So after a long time, I reconstituted my system and got some music playing, and then I noticed that the left speaker was not suddenly went out, and I went to the back where my stand is. Unfortunately, it's a very narrow space, and it's been very difficult to tighten the speaker jacks. I tightened them to a real tight level, but somehow one of the left speaker jacks, one of the two had come loose and slightly disconnected from its contact point. And then what happened is the amp consistently was not now playing, even though I reconnected it, the amp, the speaker was not actually, the left speaker was not playing. So I did a number of different things and finally switched the cables around, the speaker cables, and when I switched things around, the left, so it wasn't the speaker, because the left speaker, when I switched the speaker cables around, played fine. And when the right speaker now was out. So I have an amp which I'm playing music on the big rig on my main system after a very long time. And the sad thing was the pleasure was short circuited. I'm thinking it's because Ron said to me, yes, I was talking to him yesterday. He said, if the amp is turning on and you're getting music, then it means there's no blown fuse. So I'm wondering if there's some kind of, it's clearly the left channel that's not playing in the amp. And it seems like some kind of speaker protection circuit may have been temporarily engaged. I've disconnected the power cord for a long period. That hasn't made a difference. I'm thinking it's a simple fix, but so I'm just wondering what your ideas are in terms of how I could resolve this.
Siddhartha, have you tried switching the input signals to eliminate the preamp?
Yes, I have tried switching the input signals.
Okay.
Reverse them at the preamp end, reverse them at the amp end, and so the key test was switching the speaker cables around, finding that the right speaker was not playing anymore. I'm thinking, where do you look for, or how do you know what the protection circuit looks like? Is it sort of similar or different in different parts of the circuit board down where when you open it up?
What is the amplifier?
It's a German amplifier that's a solid state. It's called the Aaron Millennium Mark II. 90 watts, 118 to 490, something like that. Yeah. Very, very nice sounding amp, actually. I was quite surprised by how solid state it sounded. In combination, of course, with the tube preamp that I have.
Well, so Siddharth, what you said was that the one way the left channel wasn't working, and then you switched the speaker wires so that they're operating off the opposite channels, and then the other one didn't work?
That's right, exactly. And that's what confirmed. So in each case, the left channel is not the left two binding posts. When you connect speaker cable to them, you're not getting any sound, in whichever, speaker you connect them to.
Is there any kind of selector switch on the amp itself, or is it just one connection and that's it?
Yeah, it's one connection, and sadly, rather, that's one of the things it's not well engineered at the back. I mean, it's a very tight space. The two binding posts are too close together, so you have a hard time once the cables are in there, especially spades. I have taken a sort of, I don't, after this ordeal I've been through to try to tighten the speaker things, I'm like, why do spades? They're very difficult to work with. Maybe they sound better somehow, but yeah, so there is no switch at the back or anything, selector.
It's like,
Awesome.
that was like Rene's preamp question. It seems like those selector switches and then other panel controls are my most common place where something like that will happen. You know, and it's a lot of times you can figure it out by wiggling it. But if your power amplifier doesn't have anything like that, if it's just like you put the signal in and that's it.
That's it. Yes.
Yeah.
It's
possible,
you know.
Siddhartha, that that when the speaker wires came loose at the speaker, that they might have shorted together?
Well, I see. I wasn't. Yes, it's a possibility because you know what I saw was the end result, which was a thing that was loose and it wasn't close to the other speaker. You know, the one of the two came loose. And now I'm not sure when it came loose, if it contacted anything, but what would be the sign of shorting? Would there be any smell or you know?
No, probably. It's very possible that this amplifier has no protection circuits and that somehow the speaker wires got shorted and it blew out the output MOSFETs.
Yeah, exactly.
These MOSFETs are very fast. They can go in nanoseconds. So
Oh,
wouldn't be any, you wouldn't know. It would just stop working.
Phil, it looked, yeah.
Inside the amplifier, if there's any smoke, because sometimes when the MOSFETs go, they short circuit and then they burn up, you know, source resistors or some other attached parts, and then you
well,
can,
no, none of that has happened. It's like nothing. There's no smell. Nothing. It's just like, and the other terminal is working, and the amp powers on as usual.
yeah. Whatever it isn't causing the fuses to blow or anything. Yeah, I don't know what to say as far as short circuit protection.
Well, I looked on the web and
are not non-resetting. I mean, they usually just protect during the moment of overcurrent and then they release. So unplugging it would have discharged any capacitors that were, you know, holding it in protection.
yeah, I think you should email their tech support, their info@hifi.net, and you could ask them what, you know, if there's an output fuse or something like that.
Oh, okay. That's a good idea.
Could be a fuse inside. That's a possibility.
But yeah, if you're familiar, they have a website, and it looks like they're onto the Mark III now. But you could buy that for you know, 3,000 euros.
Yeah, yeah.
You only need half of it.
Yeah, there you go.
By a monoblock.
But yeah, they'd be able to tell you real quick. I didn't see any. They don't post any repair data on their website, but I'm sure an email they'd be able to tell you if there's a fuse you could replace.
That's a great suggestion, Dana. I could do that. Yeah.
Hey, so Rene, you were gonna give us a stay-at-home trip report.
Yeah. Well, a couple of things, I guess. The main thing I talked to Dana about the other day, I think it was the last Northwest Audio meeting announcement. I think Max sent a link to the Los Angeles Orange County Audio Society saying that we've been invited to a Zoom meeting on the 11th, the evening of the 11th, with Andrew Jones. Now, if you don't know Andrew Jones, he's probably one of the foremost loudspeaker designers in the world at this time. He's responsible for the TAD reference 1, in case you know what that is. It uses concentric mid-tweeters and a mid-range speaker, which were with cones that were vapor deposited beryllium. This is, when he was working for Technics, and they had unlimited amount of money to spend. So $85,000 loudspeakers, interestingly enough, when he first showed them at CES, I happened to be there at CES, and I spent a lot of time in his room because he was using the Berkeley Audio DAC as his reference DAC to play files. So I spent a lot of time listening to the reference ones, and to my mind, they were the best cone loudspeakers I had ever heard at that time. I mean, they were just wonderful. They played anything well. They were especially revealing with female vocals. I mean, they were just so present, clear, nothing strident about them. But they played orchestral music and big band jazz and everything just fantastically well. So, and of course, Andrew happened to have, at the time, he happened to be in a very good large room, so everyone could appreciate the loudspeakers. But anyway, so Andrew did give the talk. I tuned in. It was, he talked for 2.5 hours. He answered over a dozen questions at length. He didn't hold back anything about his design processes or his testing methods or anything. Anybody who's doing loudspeaker design should have watched Andrew. Anyway, he's a wonderful speaker. He's very together. He enunciates well. He presents well. He's just, you can tell he's really involved in what he's doing, and I say one of the best public speakers. So they asked him about various things, about what he used for his preferred cone material, which of course was vapor deposited beryllium. But if you don't have that, he uses aramid, multiplied cones for his mid ranges and tweeters. And he says he doesn't like beryllium domes because stamped beryllium doesn't sound right. It breaks up, has breakup modes that are not very friendly, in spite of the fact that it does go out to higher frequencies than aluminum or whatever else. He still prefers the aramid cones. Now, of course, what Andrew has been doing in the meantime, of course, he's been designing these affordable loudspeakers for ELAC, a German company, and you've probably read some reviews on them. I mean, they're in the hundreds of dollars. He has different versions, and some of the higher price models use concentric drivers for the mid tweeters. But his philosophy at this point is, somebody asked him, do you want to go back and design something better than the TAD reference 1? And he said, no, he said, I think what I'd like to do is design a loudspeaker that many more people could afford that sounded at least almost as good as the TAD reference 1. That's what he wants to do. That's his business. So he's really happy doing what he's doing now. Anyway, he does like the concentric mid-tweeters because of the time alignment. He says you can get over the problems of the edge reflection by using a proper surround. He said the big problem is the roll surround interferes with the tweeter at around 8 kilohertz, and says you have to use the proper surround shape to get over that. But he said other than that, they're very good. He thinks that the LS50 concentric driver is at this point one of the best solutions to the concentric driver. The other advantage, of course, to the concentric driver is that you end up with a waveguide with the proper cone tape, a waveguide for the tweeter, which brings the tweeter response, dispersion more in line with the mid-range and the rest of the system. So he said it's a better way to integrate the sound. Plus, it gives time alignment because the tweeter is now moved back, which is needed in order to more closely time align it with the mid-range and the woofer. So anyway, those are a couple of his little things. Anyway, he talked about cabinet design. In the TAD reference 1, of course, they used about 50 sheets of stacked 1-inch plywood, which was cut out. I don't know if you've ever seen an inside view, but it's worth looking at. A phenomenal design. Every piece was a different shape inside to provide internal supports and everything. And he said the important thing in loudspeaker design, beyond choosing the correct drivers, is the big problem is the coupling of the frame of the driver to the cabinet. And he said the acoustic distortion, the reflection, people worry about the reflections from inside the box back to the cone. He said the cabinet resonances and distortions are 20 to 30 dB worse than that. He said it's really important to make the box correctly, okay, because that's where most of the additional resonance from the back of the speaker and from the speaker shows up, is in the cabinet walls. So I know Dana's been onto that with some of his cabinet shapes and so on. And he says, you know, make the first resonance of the cabinet above the cutoff frequency of the driver in use, and then it never gets excited. So very interesting stuff. So anyway, he says, yeah, as far as distortion, people worry about Doppler distortion with concentric drivers. He said it's not. Doppler distortion is almost inaudible. He says it's not as important as all those other distortions, the nonlinear distortions and the cabinet leakage and stuff like that. He says we just don't hear Doppler distortion that much. And I think he described an experiment where he determined that. And I don't remember what the hell it was. I didn't write it down, unfortunately, and it's missing me now. But he did another interesting experiment with anechoic chambers when he, I guess, at Pioneer, when he had a very large one. He said it was room size. It was huge. He said where you could really, you know, be anechoic down to fairly low frequencies. And what they did is they put a loudspeaker in the excuse me, in the anechoic chamber with a microphone, and they played the loudspeaker at different levels, increasing the level progressively by 10 dB each time and recording. In other words, that, you know, so, but dropping the microphone level that was recorded. So in other words, what you're hearing is the speaker's getting louder, but the microphone's getting softer. So if you listen to this as a string, it sounds the same loudness. And the idea was that for people to determine what it is that loudspeakers do when they play loud. And he said there were two things you heard. One was the high frequencies got muffled. And he said that's due to the thermal compression, the problem of the voice cord heating up. And then the other one was the bass gets mushier. Again, the thermal problem, because the voice cord resistance increases, the damping decreases, inversely, etc. So it sounds kind of muddier. So he said that's the difference. So anyway, so he's done many interesting things to test out his hypotheses. But somebody asked him right off from the beginning. He said, "Well," they said, "what do you use for a reference? You know, what's your reference for the sound of the speaker?" And he said, "You know, what is the reference?" He said, stereo is based on an illusion. He said, the idea that you can recreate, you know, with two speakers, another space or another, you know, sound. He said, the reference is me. I'm the reference. He said, I have to decide when the speaker is voiced correctly. He said, that's ultimately it. And he said, you do that by going to a lot of, you know, live concerts and listening to many things. And then when he's working on his loudspeaker, he plays it in many different locations with much different equipment all the time. Always plays it with different amplifiers and different sources and so on, so that he can hear it under as many possible conditions as he can possibly do. And that's how he determines when he has it right. So, a wonderful guy. Anyway, sorry you missed it. At the end, okay, one of the members of the Los Angeles Orange County Audio Society mentioned that, well, if you're interested, they recorded it, of course. If you're interested in the recording, just send me an email and I'll give you a link. Well, I did that right away. And, you know, also sending them, you know, an email thanking them for the invite and what a wonderful presentation it was. And I have not heard one word back from those guys. And I emailed him plus the president, so nothing's happening. I don't know what it is. Dana went to the site yesterday and it's down. So where are they? We don't know. In any case, if I ever get a link, I will forward it to the group because you really should listen to Andrew's lecture. If nothing, he has a wonderful speaking voice. You just listen to him because, oh, that's another point. He started
Thank you.
out by giving his background as to how he got into this. I mean, listening to tinny little radios and little, buying little tiny home speakers and so on, thinking they were the greatest thing. He goes through this whole evolution of how he got into loudspeaker design. He was going to do something else in his life, but then it just fascinated him so much. He ended up going forward and became a loudspeaker designer. So the whole thing is just a wonderful presentation. And he spoke for, I think we took a 5-minute break, but he spoke for 2.5 hours. I mean, and didn't lose his voice. So it was definitely, I said, so having a link will be good because then you can take a break and listen to it. Because there's a lot of information in there to absorb. There's a wealth of information. Right? For anybody that's designing loudspeakers or listening to loudspeakers, Andrew's a great resource. So that's my thing for today. Okay, what else do I have? I have here, let me show you. I have a new picture of my workbench. You see? Better. That's a real workbench. That's how it is the day before yesterday.
Nice.
And what did I do? Well, what I've been working on is, you're probably all familiar that I originally years ago got some parts, leftover parts from the Storovix Alpha 1 amplifier from a friend of mine who worked with Mila. And among that, well, of course, I used up, there were 4 output transformers and 4 power transformers. So that made 2 sets of the Storovix Alpha 1s, which I built up and sold. Okay, I think Rich Weed still has pair 1. And I sold the second pair to Dick Mueller. And after when the estate was liquidated, Sam Purvine bought them from the estate. So Sam now is enjoying them, and he thinks they're the greatest amplifiers he's ever heard. So that's nice. Okay. Mueller did a good job. I think Bud did a fantastic job with the output transformers. That's part of it. Anyway, so I have a lot of other parts left, among which are, of course, our output tube, but also lots of chassis, 6 or 8 chassis that were the imperfect chassis. They have these little red stickers on them, with arrows. There must be a ding here because they were welded steel and heavy chrome plated, and so they were pretty nitpicky about how they look. I looked at some of these little arrows and I can't see what he saw, but there's something there anyway. I guess under a microscope it shows up. So anyway, so I have a bunch of the chassis parts. So I decided, since I'm sitting around this winter, what shall we do? Well, it'd be nice to have a kit to build. So I said, it's nice to have the chassis already punched out. Then I don't have to go out in the garage where it's cold and get out my Greenlee punches and my drill press. So I decided to put together 2 more amplifiers because I had 2 things that were useful. One was a set of toroidal transformers from Max's project, which he bought, and then we determined that they were not quite the right voltage, so he gave them to me and bought another pair. Okay, and then I have a pair of output transformers that I got from Bud years ago to build a higher power version of my my tube input solid state output amplifier, the Trover transformer, and then I never did that. I mean, I played around with the transformer at various times. And anyway, so I decided, well, I'll stick the toroid on the chassis and the output and the transformer on the chassis. So I'll have the things I need. I have all the parts for inside tube sockets and all that. I even have a stack of the original PC boards. Like there must be a dozen of them. They were wrapped up, so they're nice. They're not oxidized or anything. So I bought some gold-plated printed circuit mount tube sockets for the boards from China, which arrived a few days ago. And As I say, I've got a stock of 6 DJ8s. It uses 4 of them. And a lot of the output tubes, the horizontal output tube that was used in the ELAC amplifier. So I've decided to put together some of these things. I can show you here. That's the underside view of the chassis.
Oh,
wow. You can see the board. Let's see, how do we do this? There we go. That's kind of tricky. The board is, oh, well, there it is. There's the board. And then there's several boards. You can see not boards, which is nice because you have a board for the power supply over there to the left. Over to the right, you have the board that gives all the lower voltages filtered. I had to add a little transformer up there on the upper left for the bias because the Droid only had the high voltage and the filaments. So anyway, so that's one shot of the underside on the way to completion. At this point, it's I think it's completely wired and it's ready for the smoke tests. I haven't done this yet. So that's always the, you kind of like get warmed up for that. All right, let's see. I feel good this morning. I've had my 2 cups of coffee. Let's see what happens when we turn up the Variac. So there you go. So that's the next phase. There's the old workbench. There's the new workbench.
How many watts is it, Rene? How many watts?
We don't know yet.
Oh.
I mean, it doesn't want to switch. Okay, it wants to go back to my old workbench. Oh, well.
but it might be 50 or 60.
How many watts it is? It's calculated to be, it's going to be somewhere between 150 and 200 watts. Now, the output transformer was designed for 80 watts.
Wow.
So we'll see. Of course, it's a very big 80-watt transformer, knowing, if you know Bud and his designs, they tend to be over-designed. So I suspect we'll get somewhere above 100 watts. Now, the question is, will we get 100 watts, somewhere over 100 watts, or will we get smoke? That's what we're going to find out. But yeah, one of these days soon.
Right.
Anyway, there'll be a pair of these things. It's not that I need more amplifiers to listen to, but anyway, it gives me something to do because they're monoblocks. So I've only built up that one. If it works well, once I've finished tweaking it and adjusting it and deciding, how I want it to be, then I will rip out the driver board that's there because that was built with the old sockets. Build a new one, and then build a second one, and then wire up another chassis. And it takes a lot of time. I mean, it's been a couple of weeks worth of work to get to that point. So, of course, once you've done it once, the second one goes a lot easier because now you know what it is you want to do. You know exactly what extra holes you have to drill in the chassis and what order you have to put things in. So that's important too. It's a pretty tight chassis. I would never design an amplifier with a 1.5 inch depth of a chassis. That's very tight when you've got all that stuff in there. So it's not a lot of room to pack things. There's not a lot of leftover room. What amazes me is that Bud's son Sam is actually replacing the coupling capacitors of 2 sets with these big Duelins or whatever. I mean, I don't know where he's going to put them. I mean, I use a little, WEMA, MKPs, because that's what fits on the board. But, there isn't a lot of room in there to put 1.5 inch diameter, 3 inch long capacitors, not 4 of them. I mean, I don't know what he's going to do. Somehow he's going to get them in there. So we'll see. So that's, I guess, what I have to say. I've got myself.
Oh, cool.
Fun. Anyway, that's what we're doing. Oh, I know what I wanted to say. One more thing. I wonder if it would be possible in future to start the meetings at 1 and go to 3 o'clock. Is anyone opposed to that? Because it kind of interferes. I like to have lunch at noon and so on. So by the time I've had my cups of coffee and gotten everything ready, it's pretty hard to get ready for a meeting at 12 o'clock. I know we used to do it, but that ended up being lunch or breakfast at 10:30 at Whole Foods. So, yeah.
Yeah, I think we can do it.
Does anyone have a
Well,
problem?
I muted everybody so they can't object. Yeah.
No, you didn't unmute everybody. Or mute them or whatever.
Yeah.
There was a swishing noise while you were speaking, and so I was muting people to see if I could find it. But I think actually the swishing noise is from Rene.
Now, you know what? I missed it because I don't know. Rene doesn't come in real clearly, at least on my system. And what exactly did you want to do again?
Start the meeting at 1 and go to 3 o'clock.
Oh, 1 to 3 o'clock.
Yeah.
Oh, yeah. It's okay, I guess.
Yeah, yeah, we can do that.
Yeah, that way Rene can sleep in a little bit longer.
I know. Yeah, me too.
Or Terry, one of them.
I got up at 10:30 this morning, so it was a little rough. I almost didn't make it at noon.
Yeah, yeah, me too. This retirement stuff's for the birds, isn't it?
Oh my gosh.
I'll probably be going to sleep by 3.
There you go.
Yeah.
All right.
Hey, well, thanks for that. That was great. Yeah. Oh, I was going to mention on the maybe we should reach out to the speaker, the man that was talking, because I imagine he may end up with a recording of himself speaking, or maybe he has another recording where he gave the same talk somewhere else. But just in case we don't hear from the Audio Society.
Yeah, if I can get a contact for Andrew, I think I would ask him. I said it'd be nice because I'm sure he'd love to give a Zoom meeting for us.
Yeah, well, or he might even have it posted somewhere else already, or who knows. But it'd be great to pursue that. And
I think he likes talking about his design work. I think he's noted for giving good talks.
oh yeah, most married guys are looking for somebody to listen to them.
Yeah. Okay, I took that personally.
Yeah.
Are we still sharing? Are we still sharing?
Go for it.
This is pretty mundane and a small thing after the things that Rene had to talk about, but recently I've been working on an old Macintosh solid state amp. It was one of their first generations, a 2505. It was given to me because it was distorting pretty badly in one channel. And I spent 2 or 3 days digging through this thing and replacing transistors and checking resistors. And finally, it turned out to be a screw that was too long in the barrier strip on the 16 ohm connection, and it was hitting the chassis. It was about 1/16 of an inch too long, and that was the whole thing. That channel was flat topping or going really wild on the tops of the sine waves I was feeding into it at above a certain voltage, and it wasn't a dead short, but it was still, you know, seeing a low enough resistance. And when I started measuring the 2 channels, and I had a guy on Audio Karma that says, well, try pulling all of the screws all the way out on, they're the old-fashioned barrier terminal strips. And before I even got to it, I thought, oh, I know why he's telling me that. And sure enough, the 16 ohm screw was about 1/16 of an inch longer, and without a lug under it, it was going all the way in and touching the chassis. And that's all it was. So I just thought I'd throw that out there.
Nice find.
That is a great find. Wow.
I've heard of that happening before, but I never thought about it on this one. So anyway, just for the record, in case anybody else ever comes across something like that.
John, that just shows that you're too smart for your own good.
Yeah, I had to have another guy tell me to look for it. But I know how to cut a screw off.
There you
Yeah.
go. That's fantastic. Oh my gosh.
So now I got a free Mac and it sounds great.
Wow.
All right.
I am jealous. Go. Yeah. Does Dave have anything to talk about this month?
Well, I've got, a while back I talked about, I think I discussed stuffing a vent to get the vent tuned right. And I think I just talked about it, but if there isn't enough time this time, I can bring it up next time. I've got some graphs and I've got a working file in that DATS system that really kind of explains it better. Might take about 10 minutes if you want to do it today, or otherwise we can do it next time.
Go for it. Yeah.
Okay.
Hey, John, or
Are you
Dave?
able to do a screen share on my screen?
Oh yeah. Hey,
Okay.
yeah. Terry, you wanted to say something? I'll set the share up.
Okay.
Okay. I was wondering if Dave might use a clicker too, just to show us how that works.
I can talk about that.
Okay.
I don't have that set up.
It's not real hard.
I know, but I'll show you the circuit of it and describe it. And if you want to do a screen share for me, Dana.
Let me see if I can do this. I think I have to do, I've done this before, so it's, I know it's possible. How do I do it? I think there we go. I get the right menu up, I can make you the host.
Okay.
Okay, there you go. So now you should have a way to do it.
Okay. Oh, so I just hit a button that says share screen?
Yep. And then you pick which one you want to share. It'll show the different screens on your computer.
Okay, so here's one here. Let me start out, maybe if we've got about 10, 15 minutes, I'll try to go through this. I went through the forums and I tried to glean some information off of it. So I ran through several days to try to find out information on the click test and anything else I could. So I found 4 key points and I kind of collected them right here. Number 1 says the stuffing should be teased and evenly distributed in the vent. Kind of makes sense. You don't want a big hard wad in one end. Number 2, you know, with a vent, you'll get 2 impedance peaks. And when you get it stuffed properly, the lower peak will be mostly flattened with the right amount of stuffing. And then they talked about the click test. You'll hear a definite clear pop when the right amount is added. Otherwise, it'll be a muffled or dull thud sound.
Right.
And number 4 is if you increase the amount of stuffing beyond that point, the lower peak can be flattened more on your impedance, but bass response will suffer, be reduced a little bit. So I'll keep those things handy. So I thought, well, I went ahead and did the click test. Let's see. I found a link that showed a typewritten description of the click test. So there's a little circuit there. You put a battery in there and a little switch.
So we're seeing your window that shows several files. I see File Manager.
Okay. I opened up one file that just shows.
Try a different window.
That one?
Well, so when you go back to sharing, and then it should show all the different windows you have open. Yeah, right now we see the, you know, I can see click test.png, vent stuff.png, vent stuff.tzz.
Wait, okay.
So we see the file window. Yeah, you got to be real careful when you click. It's easy to click on the wrong one.
I probably did.
I often do that.
Well, I got things minimized and I can't see how to maximize it back up again. Oh, there we go. Do I do a new share?
Sure.
Okay, so what, I have to double click on something?
Well, so when you click share, it should show a little window with lots of all the windows you have available, and then you
Okay.
pick one of those.
Okay. Does that one come
There
up
it is.
now?
Yep.
Okay.
So now we see a schematic.
Okay. So there's your little circuit for making a clicker, and it tells you to use a toggle switch or push button switch and a 1.5 volt C or D size battery. And it tells you how big of a resistor to put in there. If it's not known, put in a 1/2 ohm. So I rigged up something there with some alligator clips, and it was kind of temporary, and I didn't make a very good permanent one, so I'd have to redo it again. I've got my prototype speakers totally dismantled at the moment, so I can't demonstrate it for you. But anyway, so there's the click test. And according to the descriptions, you'll hear a distinct pop when you get it right. Otherwise, it'll be kind of a dull thud. Well, what I noticed when I was doing it was I had kind of a broad range of amount of stuffing to put in there where it sounded pretty distinct pop. And I thought, well, maybe there's a way to measure the impedance that they talked about and see if I can dial it in just to the optimum, or, you know, something close to that. So, okay. So what I'd like to do is, okay. So does everybody see a graph right now with Twin Peaks?
Yes.
Yeah.
Yeah. Okay. So that's your typical, this is a screen, this is a working file of my screen on the DATS system. And it's got Twin Peaks with a vent the proper length, and you get two pretty evenly height peaks, and the trough in the middle corresponds to your tuning frequency, which is right about 39 hertz, it looks like. So that's what I started with. That is a vent with no stuffing in it. So what I did was I took a scientific handful, which ended being about 7 grams of some polyfill, that white Dacron polyfill that you get down at Joann's Fabric, just because it's cheap and readily available. And so I started putting in 1 handful, which was 7 grams. And there you can see the result of that. I measured again in that purple line. You can see that left-hand peak starts dropping down pretty dramatically. And so I thought, okay, well, let's add another 7 grams. So now I've got 14 grams in with that one. Oh, it's almost flat completely. So a couple of things are going on, I noticed. Not only is that left-hand peak dropping down, but the trough in the middle kind of shifts to the left. It was 39 here originally, and now I'm looking at about 38 or 37 on the first try, and something else closer to, it's moving toward the 30 hertz a little bit each time.
That's right.
And the other thing that happens is that right-hand peak also drops down in height and shifts to the left a little bit so far. So I added another 7 grams, so I'm up to 21 here. Well, it looks like it's not flat over there. I went a little bit beyond the flat plateau, and on the right-hand peak, it's starting to go back up again.
Yeah.
So it's somewhere between those last two, I think, is where would be optimum. And that kind of corresponded to what I heard on the click test. You're starting to lose a little bit more of the bass as you add a little bit beyond there. I put another handful in just to see more. And then the final result was I closed the vent altogether, and I get one single peak.
Oh, nice.
So you can really see the progression of that with this graph. I thought that was really interesting. It's kind of hard to keep track of all those, but with the working file, you can shut things off and, you know, turn them off, and you can.
Yeah.
So here's the closed box, and here's the vent proper length. So I thought that was a little bit more descriptive than the comments that I gleaned off of the forums in a week's time. So
Yeah.
So did you memorize the sound of the click?
Well, when I had everything assembled, I had to take the top off the box to change the amount of stuffing in the vent. So that was kind of a pain each time. So, but I did get it down pretty close. I settled on somewhere between the 14 and 21 grams. And I think I settled on 20 grams in the end because that amount seemed to be filling the vent mostly, and there was no dead air space in there. It kind of filled the vent neatly. Yeah. So I settled on 20 grams, and it sounded about the same. I couldn't really detect a lot of difference in the pop sound with my ears between 14 and 20, but I thought it was interesting. It shifts that tuning frequency down a little bit up to a certain point. So I thought that was kind of a neat little exercise I ran through. I thought I'd share that with you guys.
That's excellent. Wow.
Dave, what did you play some music through the speaker, A and B, before and after kind of thing? And do you have any general comments about that?
No, not really. I wanted to tune it, get it as close to best tuned on the vent before I started listening to music. And it actually does have some nice bass with it. It's nice and tight. The reason I did that to begin with was the woofer that I had a Q of about 0.65 or 0.7 in free air. Yeah. So when I put it in a box, it went even higher than that. So I wanted to relieve that pressure in the box and get a nice tight bass out of it. I think I achieved it pretty well. It sounds pretty good. So
it sounds a little bit like what they did with the early Dyna, like the Dyna A25, where they took a 10-inch C's woofer and put it in a fairly small box, and used a stuffed port basically. So maybe that's kind of the formula: is a higher Q woofer, a smaller box, and then a resistive port. And it seems like similar kind of a.
Yeah, that was their leaky cabinet design.
It'd probably be easier to get a vent or get a driver that has a Q of between 0.4 and 0.45 to start with, and just build your box. Just build the box with a ending result Q of 0.6 to 0.8 with a vent in it.
Theoretically, what should flattening the left-hand bump do theoretically?
Well, it makes a little easier load for your amp if you have a tube amp, for instance, which was really a target for me because my other speakers have a very high impedance peak, and the tube amp struggles on the low end down there. Okay. So if you look at this, I'm down below with my yellow line here. Even my right-hand peak is right around 15 ohms at about around 60 hertz. And the tube amp seems to work pretty good on it. So I'm happy about that.
Would the tube amp be more inclined to bloom with the higher peak on the left, or would it more get lean?
Well, with a higher peak, it's just not going to produce enough bass. It's going to struggle with that higher impedance. Although the twin peaks on this one is still under 15 ohms, under 20 ohms, it'd probably be okay. But the other advantage, like I showed, is it moves that tuning frequency to the left as well. So I gained a few hertz out of that. So
Dave, it looks like what you're doing is moving the power into the speaker. Initially on stuff, you're going to get maximum power at the tuning frequency, which is 39 hertz, because that's the impedance.
Yep.
As you stuff it, the impedance rises, but it flattens. So maybe that actually works well with the tube amp, because the tube amp probably works better with the higher impedance load, generates a little more output, and you get more bass. But in theory, if that were driven from a zero impedance, you would actually be getting a flattening, a kind of a rolling off of the bass below the first resonance peak.
Okay.
Due to the tuning. In other words, because you're not putting as much power into the loudspeaker at your tuning frequency. So, because it went from 7.5 ohms up to 9 ohms. So, but as I say, that may be just a better match for your tube amp. So it sounds, it actually puts out more because the 9 ohm load is a lot easier on
Yeah.
reflected to the tube.
Yeah. I
Interesting.
think the only other experience I had for comparison or contrast is with my TMM speakers. The two midwoofers on my TMMs are the 6.5 inch drivers are both 4 ohm. So I put them in series on the crossover circuit, which unfortunately made the twin peaks up around 40 ohms. And my tube amp really struggles with the low end on those. So that was my goal, was to get the two peaks down in the bass end. I wanted to get it down as far as I could. So it seemed like it worked pretty good on this combination. So.
Yeah. So my comment would be, so if you have that peak at 24 hertz there in the impedance with that's the unstuffed.
That one?
Yeah. So that the low peak.
Yeah.
So I think if you just took your generator and then ran, fixed amplitude and ran through those frequencies and watched the cone excursion, I think you'll see a huge peak in the cone excursion at that 24 hertz.
Oh, okay. Okay, that would make sense. It's the mass loading then.
Yeah, I think,
A lot of the excursion. Okay.
I have not built very many vented systems, but the one I built back in 2016, I had my vented system looked just like this. But yeah, what struck me was I had a very high peak. My lower peak was very high, and you could just watch that cone just ring like a bell at that frequency.
Yeah.
So it was, yeah.
Okay. So, yeah,
Cool.
so I thought that was kind of interesting.
Yeah, that's very good. Yeah, it's so nice when you got a software that illustrates the point so clearly. Yeah. Man.
I had something, as everyone knows, my approach has been more by guess and by gosh and less by engineering, kind of slowly coming into the more intelligent aspects of things. But in 2012, I built a speaker with a 14-inch JBL. It was 2.5 cubic foot cabinet, and it had both a port like was kind of traditionally the size for that cabinet for that driver, and a resistive port. And then and at the speaker contest, Gary was measuring things. Gary Gajelson was measuring things for us, and we stuck. I think it was a hymn book or something in the side room over there. He stuck a hymn book up over the resistive port, so we could see A and B. And so that combination had the regular tune port and then this resistive port on the bottom, and it had much more of a second lower peak with that resistive port covered up. I tried the same trick absolutely unscientifically, just like I think I'll try this on ones that I call the curvies, and a somewhat smaller cabinet with a kind of weirder shape, and it was just boomy. So I just covered up the. But I got a result similar to that on Gary's measurement with the tune port and the resistive port together. So it's interesting that the tune port could stay open. The regular bass reflex port that was, size recommended by JBL going back into the 70s or about, maybe before. plus this other one, and the other one was a resistive port, and it had that similar kind of effect. Made the left hand bump lower.
Yeah, cool. Wow. I know one of these days I'll have to get a resistive port and try it out.
There you go.
Apparently, I mean, I was reading about them the other day, Dana, and apparently it's if you have a little bit higher Q woofer, higher than normal bass reflex, and you want to make it work in a smaller than normal box, and still get some decent bass out of it, it's a way to do it.
Yeah, excellent. Wow.
I have an old pair of Dynaco A25s. They're the XL version. I'll have to measure them and see how they look.
Yeah.
Yeah, if you think of any good mods for the high end on those, like adding a super tweeter or something, let me know, because I've got a pair too. I don't think they're the XLs, but yeah, I think that C's tweeter kind of rolled off above 10K or so.
Nice. Yeah.
Well, here's the vent and the stuffing I was talking about using. So if just that white stuff, and then I've got a 4-inch PVC tube for my vent. So I was just adding more stuffing in there until I got up to the amount I measured that looked good. So
was that size of port, was that calculated to be a proper tuned for the woofer and the cabinet?
Yeah, there's that loudspeaker design cookbook has some formulas that tells you can calculate the minimum vent diameter that would be suitable for that box and that driver based on the X max and the box volume, I think, and the surface area of the driver. And so it looked like 4-inch was about the smallest I should use. And so I went ahead and tuned the vent. I got the right length of it down to where I got those twin peaks about the same height to start with. So that was another process before I started this altogether. So.
Wow, cool. I like it. Big vent.
Yeah. Well, it's a 10-inch driver in that box and about a 65-liter box.
Wow.
Okay.
Yeah. Well, I had one more thing I forgot to mention. So it kind of along the lines of what Renan was talking about I've been looking for a way to get remote internet so I could take my kids on the road and have them attend their classes. And so anyway, on my searching, I found a phone company called Visible. And for $40 a month, you can get unlimited internet with your phone. And so I went ahead and signed up for that and bought a new phone. But yeah, so the beauty of it is they use the Verizon network. And so they got great coverage. And anyway, so then you can make your phone into a hotspot and connect to it with whatever you've got, your stereo, laptop or whatever. And then you could stream music wherever you happen to be from your high definition source or Amazon or whatever he was talking about. And then the other trick I learned is you can get a so Visible only lets you connect one device to your hotspot phone, but you can put a wireless router, attach that, and then you can attach multiple devices. So I could have four laptops attached to my wireless router attached to the phone, and get all the internet you want. So it's kind of handy, especially if your local internet provider happened to go down. You could use your phone as the hotspot and keep going. if you need high reliability, or if you're on the road and want internet, that was pretty amazing for $40 a month. You get a phone plan with this unlimited data, and I think they're even going to support 5G here in the near future. So there you go.
Yeah. I mean, would it potentially even be someone's only internet connection? So you cut off your cable or whatever.
I suppose it's not going to be super fast. I mean, my home connection's what 50 megabit. I think this might get you 5 megabit, something like that. So sufficient to stream, video, but it's not going to support 4 people streaming different video sources at the same time.
Okay.
But yeah, for one video or multiple audio streams, that would totally work. For those of us who used to live with 56K modems, it seems amazing,
Right.
Yeah. Anyway, so that was my.
That good find. Thank you for sharing that.
Yeah. The other thing I came across was I was digging through my bookshelves, and I found a book from years ago, the electrostatic loudspeaker design and construction book. So if anybody's thinking about building electrostatic speakers, I highly recommend this book, and I could loan it out. But it's got some neat.
Is that Roger Sanders' book?
Ronald Wagner.
Ronald Wagner.
It's the other one. The other loudspeaker builder.
Yeah, but the thing that I thought I would mention, it's got a nice. Oh gosh, where is it? Oh, here we go. There's something. This will get Rene going. So that is a tube amplifier designed to directly drive electrostatic speakers. So of course it doesn't need a transformer because it's running at the voltage you want to run the speakers at.
What voltage? I can't read it.
Let's see if I can. Looks like they've got 320 volt.
Oh. That's a.
Oh no, I'm completely wrong. It's got the output stage is at 8 kilovolts.
Okay, what are the tubes? What are the tubes?
So they've got the output tubes are a 2C53.
Yeah.
And the other ones are 12AU7,
Well,
12AT7,
right.
12AU7. Yeah. But anyway, it's just kind of a fun, designed custom to drive an electrostatic speaker, no transformers required. But
yeah, I thought of doing that at one time.
Yeah.
When I had electrostats. Boy, what a it's scary.
So yeah, it's got some, he's got some interesting projects in here. The other one that was kind of fun. Oh, well, I probably can't find it quickly enough. But anyway, it's kind of a fun book. He's got, oh, here it is. This was his concept of having, like a segmented speaker where you connect the left channel to the left side, the right channel to the right side, and then you have all these segments that are playing everything in between. So that's kind of a fun,
That's really interesting. Those are, that's a transmission line. Interesting.
Yeah. So for people,
an all-pass filter for distribution. Well, that's really wild.
So
funny.
for people who have too many drivers sitting in their closets.
Well, yeah, you could try it with dynamic drivers. You'd have to build a network, but
yeah, totally. But anyway, that was kind of a so he's got some he hit some kind of fun concepts in that book. So I recommend it. Maybe you can even find it at your local library and get it, electronically online. But anyway, Ronald Wagner, Tab Books.
Yep.
I imagine Amazon might be able to send you a copy for $3 used. Who knows?
Right.
Man, anybody else got something they want to share, or should we wrap it up? We've kind of hit 2 hours.
Wow.
I'm kind of thinking, I've really enjoyed it, and I'm kind of thinking Now the sun's out from behind the cloud here.
Yep. Time to go outside.
Yeah, I need to go back and put up my mailbox post.
It's like, I don't know if David's trying to talk to us, but he is talking.
Oh.
If you want to talk to us, you have to unmute yourself, David.
Yeah, I was gonna say I need to use up what left of the daytime to go fix my mailbox.
Oh yeah, there you go.
See you guys later. Thanks.
All right.
Take
Okay,
care.
Dave, thanks for sharing.
Thanks a
Thank
lot.
you.
Yeah, okay, well,
Okay. Bye, guys.
Bye.
bye.